Hello and welcome to the third part of our GIS and reality capture series. Today's webinar is presented by myself, Kirsty Mackie, and I'm going to focus on a high-level overview of reality capture data and visualization. If you have any questions as we go along, please pop them in the questions tab and I'll answer them at the end. First, I will start by overviewing the series so far. So throughout this series, we've been asking the question, what is the relationship between reality capture and GIS? In the first part of the series, I mentioned how key to the relationship, whatever it may be, is the spatial data. And with developments in reality capture and remote sensing technology making data acquisition easier, the lines between many professionals in the AEC industry are becoming blurred, but especially between surveyors and GIS professionals. The catchphrase, surveyors as the data managers, is quite prolific, but how this relates to GIS professionals is of key interest, because aren't the GIS professionals already the geospatial data managers? To get a bit further into this question, we've been asking our Arch and Z speakers what GIS capabilities there are with reality capture data. This has so far been focused on LAS files because that's the key point cloud format that can be used in GIS systems. Our first presenter, Hamish Kingsbury from Abley, discussed FME and reality capture. Our second speaker, Susana Gonzalez from Interpine, gave some forestry examples from LiDAR data analysed using GIS. For our first talk, Hamish gave us a fantastic demo of workflows with point clouds utilising FME and LAS tools. He investigated some Leica RTC360 TLS point clouds in Esri ArcGIS. He showed us that they had no encoded information for the automatic classification within ArcGIS. It's just different sensors. So he showed us a workaround workflow using FME and LAS tools, cleaning and then classifying the data via FME and then creating a DEM of the site. He also showed us some other capabilities, including road line extraction, visualization, vegetation enrichment, and some ArcGIS online visualizations for the outputs. For our second speaker, Susana, we got an overview of forestry and GIS, and she discussed how Interpine are monitoring forest growth using LiDAR. This enables capture of tree locations, tree heights, investigations of tree thinning over time, and calculation of crown volume and crown area. She was using GIS to show all the change over time for this, with some clever Python coding in there as well. So that brings us to me. My focus is on GIS and reality capture visualization. And today I'm going to start with a bit of a personal note on how reality capture and remote sensing technology are quite integrated. Then I'll go on to a bit more the powers of visualization, GIS and digital twins, and then provide some tips and tricks for creating your own Esri ArcGIS Online version of your point cloud. So in our first talk, we had this slide about how reality capture and remote sensing can be seen as quite interchangeable. The technology and outputs that are used for remote sensing, a subdiscipline of GIS, are very similar to reality capture technology used across the AEC industry. And as we saw with Susana, she was doing terrestrial laser scanning with multiple different kinds of laser scanning for her forestry monitoring. And it's the same technology that we're using in for AEC applications more broadly. So remote sensing is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation. And typically this is from a distance. However, it's quite a contentious area about the definition of this. Terrestrial laser scanning and cameras are also considered close range remote sensing technology. So in that sense, it's quite hard to differentiate the differences in the technology there. But you're probably wondering why there's a glacier on the screen here. And that comes back to my personal experience with all of this. So during my degree, I studied geography. and I did a Bachelor of Science focusing on geomorphology. I was looking at fluvial and glacial geomorphology, so the shape of landforms and their geology, to try and reconstruct how the landforms were created, to understand how they change over time. And for my thesis, I did this at Fox Glacier, the third largest glacier in New Zealand, to study its proglacial valley dynamics. And this is very similar to many of the things I would have done as a survey technician, and many of my customers are doing nowadays. So I got a series of overlapping ground-based pictures and then used a GPS device to coordinate them. And I used Agisoft Metashaper to create the point clouds of the site at different dates. So what you can see on the right here is those reconstructions. In the middle, B is the sparse point cloud, and then C, the bottom one, is the dense point cloud. It looks like a photo. I actually managed to dig up for you guys one of the point clouds from my degree. So what you can see here is quite a dense copy of one of the point clouds. There are quite a few gaps. So this is just where there's water running, or because of the angle, it's all based off line of sight for the overlap of the pictures. I would have used drones, but I didn't have a permit for the research I was doing. But from that, I was able to create a DEM for each site on different dates and then compare those over time. So what you're seeing on the left here is a DOD, so a DEM of difference, where I've minused the final digital elevation model from the first one. And in red, you can see the area where it changed volumetrically. It went 65 meters of change there. And then in blue, you can see aggradation. So that's where the slope increased. As the glacier retreated, the slopes collapsed around the glacier. So it wasn't just retreat and erosion, it was also aggradation around the site, which was quite interesting to see. And then this was combined with the overall retreat of the glacier of 71.5 meters back from the terminus. So this sounds like quite a different application, but the principle of calculating volumetric change of a site over time is very much what I help many people with in reality capture through my day-to-day now, and what I've done in the industry using reality capture technology, especially for surveying purposes, to calculate change. So what you're seeing here is a cut and fill example where two DTMs are being compared to calculate the change over time. So for construction monitoring or cut and fill, this is quite a key workflow. And it's the exact same technology, but there's just different purposes in the way that remote sensing and reality capture technology have typically in the past been used, although there is now a bit more of a convergence with all of this. So the technology and outputs that are used for remote sensing are very similar to the reality capture technology in the AEC industry. I don't think you can really even define them. It just seems there's different labels that can be a bit confusing. But reality capture is already very much a part of the GIS toolkit. And there's already remote sensors like Susanna going out and using terrestrial laser scanning data and processing it through GIS environments. So they're very much synonymous. So a key question here is, if it's so simple, that overlap, why is it not being used a bit more like in the crossover? And a lot of that comes back to GIS systems being set up on devices that aren't really ready for the volume of data that comes with terrestrial laser scanning. For the AEC industry, we're quite focused on fine details. People will be modeling pipes and bolts on these pipes. It can get very, very fine, the level of detail. And for those of you that have tried to analyze these point clouds in a GIS system, even on my beastie computer, it was a struggle. What you can see on the right here is one of the loading boxes, and that there's usually a blue wheel down in the bottom right corner because the amount of data that you're trying to load is taking a very long time to come through. But this is just part of the broader issue with reality capture in general. You've got the pros, that it's non-selective, so it's getting everything around you, and that enables you to remotely manage your assets better, and they're quite visual outputs. But then you've got the disadvantages that you've got all that big data management and really large PC hardware requirements. So what a lot of us end up doing is getting these beautiful 3D outputs and not really using them to their full extent. So what I've got here is an example where we're using a point cloud to extract a 2D floor plan of the site. And this is fine. Like if we're going out and doing the reality capture, it's making our capture more efficient. And that's the whole idea behind using the technology. But there is a lot more that we can do with these outputs than just going straight to CAD. And what you can see here is we've got all of the outputs I've just showed you, which are all 2D. And this is the main format that many of us are using in the industry, the DWG or the just PDF output. So this broader issue of managing such large data is across the industry in general. But if our clients' computers look like the one on the screen, then we've definitely got a problem going on. So this is where visualization comes in. And I think GIS is quite a key part to this when we consider digital twins. So if we go back to the basics, a geographic information system is a type of database containing geographic data, which combined with software tools allows the management, analysis, and visualization of those tools. The key part of this is just layering everything together. You get that visualization with all the contextual geographic information, which enables very strong decision making. And if we go into it a bit more, reality capture is a very broad area. We've got here this diagram that I love from the GeoWeek website. And it's talking about UAVs and LiDAR, airborne and terrestrial laser scanning. But beyond that, we've got all the information that we're extracting from those point clouds. So just kind of thinking beyond the point cloud here in terms of reality capture, even though that's what a lot of people assume, you've got all the information out of it. So what I've got on the screen here is a meshed point cloud, and now I'm extracting some contours from it, and you kind of get the idea. There's lots of different options you can get out of this data. So looking at the powers of visualization, if not everyone can engage with the 3D models themselves because only the people who are collecting the data are able to actually deal with it, then this makes visualization really important. In our industry, we have quite a lot of people who have a middle party. Say you're working with a council and the council is getting data from you on behalf of another stakeholder. They will still likely want to see the data and understand what's going on with the capture. So visualization then becomes key to engage those stakeholders, whether it's the public, whether it's multiple parties involved in your project. They're key for collaboration with others across all those areas, and also just to make decision making more effective by having all the information and outputs from that raw data in one place. So you want to have the raw reality capture data, the outputs from the reality capture data, the people who've then gone and modeled it, where maybe it's a BIM model or something, and you want to have that all together. And if you're going to start to get a bit more clever, you could start putting in some IoT sensors. But at the most basic level, we're going from visual display, so videos and pictures to communicate design intent or design conditions, whatever changes it may be, going up to digital twins. So what I want to share just here is a quick video of a design intent for a site. This is from Harrison Grierson's website. So lots of you are producing amazing visualizations like that, whether it's through gaming engines or different devices. There's lots of different options out there for that kind of thing now. And just to underline that message that this technology is very visually powerful, you've also got the fact that all of these sensors that we're using for whether it's the forestry or for capturing very large buildings for BIM modeling purposes, those same tools are being used within the movie and gaming industries for enhancing the realism of VFX effects. So that's all the visual effects on movies. So right now, what I've got on the screen at the top is a Leica ScanStation P40 that was used in the Joker and John Wick movies to get more realistic backgrounds for the sets. And this means that they can get quick scans, but then they're also using the RTC 360. But they get scans of sites and they can capture the lighting conditions at the time. And then they can use those colors and lighting conditions to make more realistic visual effects. So just because I'm telling you that you can use these tools to create feature-length movies doesn't mean that that's what you have to do here for your visualization. But the idea that there is the potential there is quite key. So when I'm talking about visualization, I'm talking about it as a continuum, going from those basic videos and pictures to digital twins. And when I say digital twin, please don't run away. I know we're all getting a bit fatigued of the whole argument about or debate about what digital twins actually are. But here I'm just seeing the whole thing as a continuum. So somewhere in the middle there'll probably be a basic digital twin, which is just sharing the data online. And I would say that the start of a digital twin is that collaboration piece, not just having it like a scan of your site, but sharing that and being able to talk about it. I'd say that's the starting point for a digital twin. And then as you go right through to the more mature ones, you'll be getting more of that autonomous decision making and greater degrees of collaboration and representation. But there is lots of ways to define that one. So going into that idea a little bit more, I'm going to focus on GIS and digital twins. And to start that off, I wanted to bring up a LinkedIn post I made a little while ago. So I wrote, every day we're surrounded by more and more impressive visualizations, whether it's in movie effects or gym classes. That's what you can see on the screen to the right is one of my gym classes. And it's talking about how you don't necessarily need that millimeter precision for the outputs. The visualizations by themselves for communication of design intent is often equally as important, but it is a continuum. And I actually had a comment on that post from one of the directors of Cintu, a digital twin platform, talking about how millimeter precision is also super useful and vital for many individuals in the AEC industry. And that's completely correct. Having your millimeter precisions in a place that everyone can share and use for the AEC industry is very important. So I'm going to use this definition from Stephen Witherden, who works at Becker, and there's a link there to the website where I've got these two diagrams and this quote from. But his idea that it looks like, behaves like, and is connected to the real world, I really like. So he's defining it as a high fidelity representation of the real world that looks like, behaves like, and is connected to the real world to improve understanding for decision making. And then down the bottom, they've got this idea of ideas and assets together for individual digital twins, which I think is also very key to all of this. It's what you're trying to achieve with your visualizations through those digital twins. So at the most basic level, for us with reality capture data, we'd be creating something like this, getting our point cloud into Esri ArcGIS online perhaps, and being able to visualize it and see the different layers of information with some base maps. And you see this one's actually floating around the sky. That is actually how it should look. It's about floor 8 in this building, this one. And I've got a little web map to link to as well. So just a data twin, in a sense, I suppose, is the basic starting point of digital twins, is a key argument. So if you look up digital twin, you get to Esri's website in one of the first hits, and they've got some really interesting thoughts on a lot of this. They're talking about digital twins as representations of the real world, including lots of different outputs. They say a digital twin in a geographic context represents real-world assets and natural systems, along with information models, data, reports, analysis, and behaviors in a spatial context to the natural and built world. The digital twins may be used to represent the current, past, or even future states of assets. They don't just mirror what's in the world today, but can forecast what may exist in the future. So from the Esri standpoint, a modern GIS is a powerful tool for representing a holistic digital twin in a spatial context. So they're arguing GIS is the framework can be the framework for digital twins. And I would have to argue that is a very key point there. Having all the different layers of information and being able to sync it together, as is the fundamental idea of GIS, is key. Things like ArcGIS GeoBIM, where you're able to bring more of that information together, and the 3D BIM models is very key. So there's this key idea that digital twins have a maturity continuum. So what you can see on the screen here is just going from the basics on the left of being descriptive right through to autonomous decision making. It's all about the collaboration and the amount of information you're able to get out of this twin. And this is an overview of the ArcGIS idea of digital twins. So you're going out and you're capturing the modeled and getting the reality capture data and the modeled data, and then going through and adding real-time information about your site, maybe real-time visualizations. Then you're maybe adding in some analysis and prediction models, and then sharing and collaborating all of this together. So if we're looking at a little bit more of a complex one, here I've got another ArcGIS Online one, which has some BIM models and some different layers of information for some different designs around the developments, so existing and future. So just for visually sharing some of this information online quickly, it's a really awesome tool. So you might have people going out and doing a load of point clouds, scanning of the existing conditions, and then someone's gone and BIM modeled that, and then they maybe have gone and done the design based off those accurate conditions of what's already there. So it's all interconnected. And if you look online, there is tons of platforms that are all talking about using GIS as an underlay for all of these digital twin platforms online. Lots of different elements of interchanging all the different formats. So what can you do with all of this information? I'm going to look at some tips and tricks now for point clouds in Esri Desktop and ArcGIS Online. And one of the things I'm going to look at is how you could make a basic data twin. Basic data twin, I'm calling it. So just getting the point cloud in there and overlaying some contextual information. So what many of you have seen on the picture for this webinar is these point clouds here, especially the one at the top. So for those of you that have tried loading point clouds into Esri ArcGIS, you know that coordinates are the biggest problem when it comes to all of this. I think on the top one there, I've got a global scene, but it's also not coordinated, the data. So I'm just going to talk through coordinates a little bit more and how you can get around that in the Leica system. Then I'm going to talk a bit about data loading tips in Esri on the desktop, and then just go back to the point of your visualization, so looking a bit beyond the point cloud. I am focusing here on point clouds for these tips and tricks because that is where we see a lot of problems in the Esri environment. So with laser scanning, all the ground-based laser scanning, before you add control to your site to give it real-world coordinates, it's all arbitrary. So on the left here, we've got that picture of a laser scanner. The origin of the coordinate system for that individual scan is coming from that laser position, and you're going out and you're getting all of these ground-based coordinates. So it's developing an arbitrary coordinate system based on all the points measured on the site. And if you want to make that real world, you have to pick some points within that model and then give them real world coordinates. So if people aren't going in and actually adding in their own coordinates, you're going to have uncoordinated data. And beyond that, with ground-based laser scanning, the view of many companies dealing with laser scanners is that they are inherently more accurate to go out and do your ground-based measurements, so they don't account for scale factor, which means that if you're doing really long sites, scale factor can become a bit of an issue with how you're applying coordinate systems into your data if you want to view it in a GIS system. And when you view it in a GIS system, if you are just using that arbitrary coordinate system, you're going to have a couple of issues with making the most of it, because you're not going to be able to get a hold of all that contextual information that's in the GIS system. So if you're not going out and collecting shots with a GNS receiver or a total station and getting some control for the site, then there is a workaround in the Leica system, but it's not accurate to the origin, but it's a way to give you rough coordinates. So what you can do is go and get a lens base map. It syncs in. You just have to look up the location of the site. And then if you import that image, you can overlay your scanning data in the location on that map, just as you can see I'm doing here on the screen. And what this is doing is it's orientating your data north. And then once your data has been orientated north, you can go into the advanced UCS creation tool and you can pick a point and then you can set a coordinate for that. So I haven't got one here, but you could go into like Lens and get a coordinate, download some aerial images or something and get an XY. So it's not accurate to the origin, but in terms of getting a rough placement for your data, this is quite a powerful tool. If you were to just send an advanced UCS without using that base map, it wouldn't necessarily be orientated north because you'd just be using one coordinate mark. Another tip here is that you can select coordinate systems on import. So this is only for NZTM coordinates. It's all based on UTM. This is using either the GPS of your RTC 360 or using the GPS of your tablet device. So the Field 360 app, if you've given it location permission, should be able to use that to give a location to your data. So that's a simple way for all of the coordinate issues. So that brings me on to some tips and tricks within the Esri software itself. So when you load it in the last file, not all systems for exporting the point clouds actually still encode the spatial reference in the point cloud. And if that's the case, it will say unknown coordinate system in the properties. You can use this define projection tool to make sure that that is set. It will still be able to read it as long as you've coordinated the data on export. You can also set a loading density up the top. This data set is about 8 laser scans, so very small by terrestrial laser scanning standards, but it took about 20 minutes to properly load. So I ended up with a bounding box, and down the bottom you can see it says drawing, so that wheel of death was present the entire time. So yeah, you can play around with the display limit and the minimum maximum density to get those to load a bit faster. The display points go up to 100,000. So a lot of these like LAS files that come in here have the option to have classifications done based on the heights of the points, but here that information isn't coordinated, isn't in the actual LAS file exported for TLS data. There are a few other options within Esri generally. You can thin out the LAS, you can create a raster, you can export a TIN as well if you want to. But to get it to an online digital twin, an online twin in ArcGIS Online, you just need to get a scene layer package. So what I was showing before was just going to export a scene layer package or clicking the publish online option. So this is an easy way to share your point clouds with a bit more surrounding information on them. You could also do this same process of just publishing it online as a web map from the Arc desktop, assuming you have your ArcGIS online account set up and everything. You could also go out and think about what you're including in that. So what I've got here is a point cloud and now a mesh. And you can see the mesh output is also very visually appealing. So this is from Leica RTC 360 data. But there's lots of other kinds of information that you can extract and also display through a basic ArcGIS online account. Having a bit of a display issue at the end of the video there, but there's some contour lines across the site as well. So at the moment, we're often not prepared to use this volume of data in a GIS system, but this whole area, from a theoretical standpoint, is getting very close. It makes sense that there would be a lot more overlap than there maybe currently is. And to highlight this, on GeoWeek News and other sources at the moment, they've been all talking about ArcGIS reality as the future for dealing with all of these point clouds within Esri ArcGIS. So showing another step in that kind of direction towards having this all online through GIS. It's also talking about how point clouds are dumb and that you might be able to get more information through this kind of a software. So something that can automatically extract all this information online and present it would definitely be a great starting point. There's also talks about getting ortho photos out of the point clouds and then doing things like crack detection on all the pictures. This is already happening for aerial and other images, but lots of potential in this space for automation. So I've gone over a few different things here, a bit about how reality capture and remote sensing are integrated, a bit about the powers of visualization, not just digital twins, but videos as well. Gone over a bit more about GIS and digital twins and given a few tips and tricks for loading point clouds in Esri. So if we go back to that original question that we started this whole series with, which is what is the relationship? We hope we've clarified that a little bit through this whole series. To summarize, I'd say the key points are there's lots of tools for LAS files and rasters from reality capture data, like the raw point clouds. But it's also a lot more than that when you consider reality capture data and what it actually is. It's very broad and it's very similar to remote sensing. And the reality capture data itself over time has become a lot more visual. So now it's also quite key for visual communication. But that data itself is foundational to digital twins. And GIS provides the framework or a framework for digital twins. So at the moment, GIS systems maybe aren't typically set up to utilize that volume of data associated with primarily TLS scanning. But that is changing with the release of new software and hardware like the ArcGIS Reality. But all the information that we're getting out of point clouds and can currently get out of it is also possible to be used right now in those digital twin environments for visualization purposes and much more. I hope you enjoyed that. I got very excited thinking through a lot of this, and this presentation was definitely a cut down version of my original input. But if you have any questions, I will go through those now. So I've got a few questions that have come in. Oh, just trying to share my webcam again. Awesome. So one of them is actually a comment about the video from Harrison and Grierson. I just wanted to mention that for that video, it's got a much faster frame rate. If you actually look up Matai Dam on YouTube, you'll find it. They've got a few visualizations on there. I was having a look at a few that are online. The question was actually about how that video was created. I don't know, so and I probably wouldn't be able to tell you even if I did, so sorry about that one. Next question I got was about the PC specs, which I'm using to load those point clouds in Esri. The PC specs I'm actually using are really high, so if anything's going to be able to handle it, it would be my PC. It's got 128 gigabytes of RAM, multiple cores and quite a good CPU. But I think the main problem that I've got with that data set is, even though it was only about 8 scans, I didn't apply any decimation, so it's quite a large file. Earlier on today, actually, I was helping out a client with a file that had only 20 scans. It was an 11 gigabyte E57, and we decimated it down to 15 mils, and it was suddenly less than a gigabyte, also cropped around the area. So I think a key point there is more about the size of the data that you're using within Esri rather than just the PC specs. Cool, got a few more questions here. Please, if you have any more, keep them coming in. Got one about scale factor and scanning, and how I would apply, how I would get around scale factor issues with scanning. So for that one, if you're using local coordinate systems, that would be my first tip. Don't try and use global ones. If you're using local coordinate systems, you can choose to either, in the Leica system, it might be different for other scanning softwares, but if you can spread out the error. So if you've done, you'll only really get the scale factor issue on your coordinates if you're going for really long linear areas, as I kind of hinted to with my slide. So if you've scanned more than a kilometre down a road, that's where you might start to see around 40 mils of error there. So you've got two options basically. Number one, let the error propagate out along your scans so that your scans aren't treated as one overall object, but they then slightly move separate to each other. And then you're propagating it out along the length of that site, but holding it fixed to those control marks. The second option is you could split the scans into segments and then coordinate those separately, and then any errors you've got between fitting those coordinates to the overall scanned point cloud will be reduced. But then what you might find is if you're coordinating two separately, there might be a slight offset with some errors that way. Yeah, I think that's the main one for scale factor and scanning. A few more questions here. Got two more, I think. A controversial one there. Is the point cloud a digital twin? So for that question, there's lots of disagreement about that. Some people would argue yes, because they've got all the measurements there, they can see everything, and that's a big power of the visualization of point clouds, being able to go back afterwards to the site and remotely manage it. I would argue that perhaps it's more, a digital twin is more started when it comes to the degree of collaboration. So that's what I was hinting at with those data twins, and why I was talking about having the point cloud on like ArcGIS Online via the SLPK route. And for that one, that's what I was calling like a data twin, a very basic digital twin with all the layers and the point cloud that you're able to like share it out and collaborate. So is a point cloud a digital twin? Some would say yes. I'd be more inclined to say not by itself, but it can be if you're sharing it online. Maybe that's more of the start, the more greater degree of collaboration there. Looks like we've got one more. Have you encountered tiling issues with dense point clouds in ArcGIS Enterprise and ArcGIS Online? It seems like the platforms are not optimized for scans that are dense vertically and horizontally. I haven't come across tiling issues so much. I did try separating out some of my point clouds a bit more. That's where I'd go back to like the loading density of the points within the software. My general tip there would be to decimate, but it's more about if you're going beyond the kind of decimation that's useful for the point cloud. If you decimate it out so much that it's no longer visually as useful to you, that's where I'd maybe consider whether or not you're using it. So sorry, I'm not sure about that one for large data sets. Although if you have that data set and you want to email me and have a look at it together, I would love to. Awesome. I'm just having a bit more of a look here. There doesn't seem to be any more questions, but if you do have any, feel free to email us at info@globalsurvey.co.nz. Okay, thank you. Bye.